So this is the second basic lecture. Basically we will study the logic gates. Logic gates. Till now we haven't started the questions. We will start, but after knowing everything. Okay. So as you know, maybe in the high school you might have studied how does AND gate works. So AND gate. So this is the AND gate representation. You have an input X, you have an input Y, and this is your output F. So F can be written as X and Y. So this symbol is for AND, dot symbol is for AND. So if you see the truth table is this, like this. X and Y are the inputs, so this is the output. We draw like this. So you give 0 and 0. Let's write 0 0 0 1 1 0 1 0 1 1. We are writing this in binary. So this is a binary. Okay, binary. So what will you, if you give X equal to 0 and Y equal to 0, if you give both 0 and 0, what will be the output? So 0 and 0 output will be 0. If I give X as 0 and out Y as 1, so 0 and 1 will be 0. These basic things you know. So if I give 1 and 0 will be 0, 1 and 1 will be 1. So whenever it is on from both the sides, this will be 1 and this will be 1, the function will be 1. Okay, so this is how the AND gates work. Okay, so let's move to OR gate. OR gate. OR is something like this. So there is an input X, there is an input Y, and this is the output F. Okay, and F can be written as X or Y. X plus Y can be, so plus symbol is for OR. So this is X, Y, and this is F output. This is 0 0 0 1 1 0 1 1. This is the truth table. Truth table basically is the table which shows us the input and output relation. Okay, so 0 and 0 will be 0 or 0 will be 0, 0 or 1. If you put this 0, this one or 1 will be 1, 0 and 1 1, and this one 1 or 1 will be 1. So if we look at this gate, basically you know OR operation between 0 and 0 is 0, 0 or 1 will be 1, 1 or 0 will be 1, and 1 or 1 will be 1. If you move to the next gate, which is the NOT gate, also called inverter, in okay, just a minute, inverter. Okay, it can be represented like this. There is a triangle symbol and a node in front of it, and if you give it can only accept one input. Okay, so, and one input and one output. So for NOT gate or the inverter, there is one input and one output. Rest can be 2 3, for this can be 3 2 1, so anything. Okay, minimum is 2 and maximum it can be 3 4 5, whatever. But for NOT gate we can pass only one input and one output can be like obtained. So what will be the truth table? The truth table is like this: X. So if this is not, so output will be not X. So this is X, X naught. It is 0 or 1. We can give X as 0 or 1. So this will be 1, this will be 0. So if you, let's move to the next gate, which is NAND gate. Okay, NAND gate is something like AND a NOT in front of it. You give input X and input Y, and you get a output F. So F can be written as X and Y. So there is a NOT, so we give a NOT on the top. So the truth table is x, y, and f is the function. So this is 0 0 0 1 1 0 1 1. So this one 0 and 0 will be 0, but not of 0 and 0 will be 1. 0 and 1 is 0, but the not of 0 is 1. So all these will be 1, this one will be 0. Okay. So if you move here, NOR gate. So NOR gate can be represented like this: OR gate with a NOT symbol in the front. This is the function output. These both are the input. F can be written as X or Y, like we used to write, and a NOT on the top. So truth table is like this: 1 0 1 1. So 0 or 0 will be 0, but the NOT is there on the top, so NOT will be 1. This one will be 0 or 1 will be 1, but it will be 0. This one will be 0. 1 or 1 will be 1, but not it will be 0. So if we move to the next gate, which is exclusive OR gate. Okay, let me tell you one thing before that. These both are called the universal gates. Okay, any gate can be made or composed of this NAND gate and NOR gate. If you look to their structure, it works exactly opposite of OR gate, like complemented of OR gate, and this is the complemented of AND gate. Okay, so this can be written as XOR gate, can be written as XOR. So the symbol is like this. Let me draw it. Yeah, so this is the XOR gate. So there is an input X and there is an input Y and the output of the function F. So F can be written as X and Y complement plus X complement Y. So X Y complement plus X complement Y. It can be written as X XOR symbol Y. This is the XOR symbol. So this is symbol of XOR. So if you draw the truth table, X, Y, and this is the output of the function 0 0 0 1 1 0 1 1. So 0, if you pass 0 here and 0 here, so this will be 0, this will be 1. So 0 and 1 will be 0, this one will be 0. So this one will be 1 and 0 will be 0. So 0 or 0 will be 0. So similarly, if you do the same operation, this one will be 1, this one will be 1, this one will be 0. From this you can see the odd number of ones and zeros. The odd number of ones and zeros are 1. So this is a odd 1 function. Whenever we have odd number of ones, only 1 1, not 2 ones or 2 zeros. So that time we will have basically that time we will have basically or these as 1 and 1 and these are zeros. So if we move to the next gate, which is exclusive NOR. Exclusive NOR stands for, you can write it as XNOR. So it can be represented like this. So in this is the XOR gate, and in XNOR there is a NOR symbol, same symbol, but there is a NOT symbol in the front. So this is F, this is X, this is Y. So how can you write F? F can be written as X and Y plus X complement Y complement. So this can be written as X XOR Y whole complement. So if you look this structure, it is same as the XOR gate, but there is a not symbol, so we write X or Y whole complement. So how do you draw the truth table? X and Y, this is the F output, so this is 0 0 0 1 1 1 1 0 1 1. So you write this as 0. If you pass 0 here, 0 and 0 will be, this one will be 0, so 0 complement will be 1 and this one will be 1, so 1 and 1 will be 1, so 0 or 1 will be 1. So if similarly, if you pass the values of X and Y, so this one will be 0, this one will be 0 and this one will be 1. If you look carefully, here there are even number of zeros, so there is a 1 here. When there is even number of 1, there is 1 here. See here, there is odd number of zeros and odd number of 1, there is only 1 0 and 1 1 in this place, so these both are 0. So this one act as even one function. Okay, this, by this way you can remember. So whenever we have the even zeros, you will be 1 in XNOR gate, and even 1 there will be a 1, the output will be 1. So these were the basics of all the logic gates: AND gate, OR gate, NAND gate, NOT gate, NOR, okay, XNOR, XOR, everything we finished about the gate introduction part. So let's move to the logic diagram. Logic diagram. So logic diagram is basically the diagram to represent the connection between and passing through the gates and everything. Example, F is equal to X plus A complement B. Let's say this is an example, plus Z. So there, see, if you see X, A, B, C, there are 4 variables, A, X, A, B, Z. So, and you know, X, between A, B there is a AND operation. So A is passed through a NOT gate, and after all these are passed through OR gate. So first you build a AND gate. So this is the where A, so A will be passed through a NOT gate, this is not A. Then B is connected to, let's draw another one color for B. B is connected to the AND gate, and this is the output. Okay, and the where, let's say, okay, so this is X, this is X, and Z will be somewhere here, this is Z. So these all 3 are passed through a OR gate, and this is our output F. Okay, so this is how to draw the logic gate, basic like way of drawing the logic gates. Then if we have something like this example, let's give one more example. Z is AB plus B complement C plus C complement. So how will you draw this? So A and B is passed through AND gate, so this is A, this is B. If you see here, B naught and C, take where from B naught and connect it to the AND gate, and then this is the C, and the last one is C naught. So these both, they have a AND gate, and finally these all have a OR gate. So draw a OR gate, and this is C complement, so you have to pass through a NOT gate, this is not C, okay, and then all the 3 things pass through a OR gate. So this is your output Z. So this is the basic concept of how to draw the logic diagram. Okay, if we move to the next concept, which is the K-maps. So we use basically k maps to minimize our terms to get the minimum terms and maximum terms. So let's say we have a function f a comma b, which is written as this summation small m 0 to 3, okay, this much. So this term is called as SOP, which stands for sum of product, sum of product. So this small m stands for minimum, this is the mean term, so, or this is the minimized form, so how to draw the k map of this? So you will come here, let's draw the truth table for this. So there are two inputs a and b, and this is the output f. So 0, you can write 0 1 2 3. Since there are two inputs, you will do 2 to the power 2. This is the formula, so there will be 4 like variable 4 digits. So 0 1 2 3 up to like 4 digits, 0 1 2 3. So you will write 0 0 1 1 0 1 0 1. So this will be output at 0. At 0 our output is 1. See, here the functions are given at 0, at 2 and 3. At these places our at 0 function is 1. At 1, is 1 mentioned in the function? No. So this one will be 0. At 2 mentioned? Yes. So we will have 1 and this one 1. If you draw the k map of this, so we have two inputs a and b here, okay, then so these are binary variables 0 and 1, 0 and 1. So name this 0 1 2 3. So at 0 function is 1, at 1 it is 0, at 2 it is 1, and 3 it is 1. So how will you consider the k map for this two variable, like two inputs? You will take this 2 as 1 and this 2 1 as 1. This one you can write, see, since b is changing for, let's consider for 1, then we can go for 2, okay. If you look at this box, this value is remaining constant, this column value is remaining constant, but a is changing. Here it is 0, here it is 1. So this will be b complement. If you look at this box, blue box, so again b is changing for this 0 and 1, so a is not changing, so this will be a complement. So our minimized form SOP will be f equal to a complement plus b complement. This will be your answer. In minimized form, we consider only one, okay, only taking the, we consider only taking the ones, taking the ones, okay. Let's move to another one example. Okay, if we take zeros, if we take only the zeros, so this one will be POS. This is product of sum, product of sum. So what will be this? If you see here, a and b, both the values are not changing, so it will be a complement, since a is 0, okay, and b is 1, so it will be a complement and b. Okay, let me make a small change. This one is not a complement, this is a, because a is 1 here, a is 1 here, so this will be a, okay. So POS will be, this is POS form, so it is a complement or b, product of sum. So basically we have to this plus b, okay. It's a different form of, that one was the sum of the different products, but this is the products of the sum. Let's move to one more good example. Let's say you have a function f, a, b, c, three variables, and you have something like 0, 1, 3, 6, 7. So you have to draw the truth table. So how will you draw the truth table? You will write 0, 1, 2, 3, 4, 5, 6, 7. Why 0 to 7? As I said, you will apply the formula. So 3 inputs means 2 to the power 3 will be 8. So you will have 0 to 7 as 8 digits. So 0 to 7 as 8 digits. Okay. So you will write here a, b, c and the function f output. So let's write the values. How will you write? Since it is 0 to 8, you will divide into 2. So 4 zeros and 4 ones. Okay. Again 4 will be divided by 2. 2 zeros, 2 ones. 2 zeros, 2 ones. Okay. This one will be 0 and 1. 1 0 1 1 0 1 0 1 0 1. This is the way of drawing the truth table. So how will you draw the k map? So before that, let's write the output. So function is saying 0 1 3 6 7. At these places our function output will be 1. So at 0 output is 1. Let me draw whether these lines, because it should not mismatch. So at 1 function is 1, at 2 it is not given, that means 0, at 3 it is given, so 3 is given, so it is 1, 5 not given, 4 not given, these are 0, this is 1 and this one is 1. Okay, so if you draw the k map, make a box. So 3 variables, so you can give a and b as one side input and c as this. So you will give c can be 0 and 1, a and b can be 0 0, 0 1, 1 1, 1 0. Pay attention here why I wrote 0 1 0 0 0 1 1 1 1 0. Why not 0 0 0 1 1 0 1 1? Because in k maps we follow gray code. Okay, so whenever we are going drawing the k maps, basically we will follow our gray code. So if you see here, every time we will, since c is a binary variable, so binary variables means either it has 0 or 1. A and b, a can be 0 or 1, right? B can be 0 or 1. If you take the combinations, there will be 0 0 0 1 1 1 1 0, and this must be written in gray code. So how will you write 0 1 2 3? Okay, this one will be written, this one, since we are following the gray code and we know 1 1 has higher value than 1 0, so we should write 4 and 5 here, 6, so 6 and 7 here. Okay, so let's draw the at 1 our 0 output is 1, at 1 output is 1, at 2 0, at 3 1, at 4 you see it is 0, at 5 0 is 1 and 1. If you draw the k map, so you can consider, you can take two pairs of 1, 4 pairs, 8 pairs or 16. You can take like this: 2 4 6, 2 4 8 16. If there is no pair, then you will take one, only one. So since we have pairs, we can take these two and these two, right? So these two can be written as, if you see, for these two, for only this box, C is changing, so we will not consider C. The bits which is changing, we will not consider that. The bits which is not changing, we will consider. We'll write A and B. For this box, A both, if you see here, A is 0 and 0 here, but B is changing, it is 0 and 1, so we will not consider B. So it will be A complement, because A is 0, so, and we are taking 1, so that should be A complement. And C is also not changing, so it is C is 1, so it is A complement C. If you look at this third box, horizontal box, so C is changing for both of it, but B and A and B, they are not changing, so A complement and B complement, because both of them are 0. So what is the final minimized form? It is AB plus A complement, if you see, C plus A complement B complement. So this is the answer, which is the SOP form. SOP is the minimized form. If you were to consider find the POS, then you would have considered only the zeros. So these two zeros you can take together, and this one as one, because you cannot take in pairs. So then you will write the equation for the zeros and you will find the POS form. And POS form is called the maximized form. Okay, so this is the maximized form. So as I said, if you have to draw one more, okay, so we found the minimized form, which is F equal to A complement B, A complement B, A complement B complement. So I can write A B whole complement plus A complement C plus AB. This was the form equation. So draw the logic diagram. How will you draw the logic diagram? So you will draw 3 AND gates, so you have to pass 2 NOT gates. So this is A, so the B is also passed through, so this is A complement B complement. This is the output. If you see A complement and C, take a wire from A complement and C. This is the C wire. If you draw, this is A complement, this is C, so A complement and C. This one is A complement B complement. And one more gate you need, that is, let's draw in black, which is A and B. Take a wire from A, this is A, so join it here, and take a wire from B and join it here. So this is A and B, so it is A and B. Okay, so all the three wires, all the three, and the last one, you have to pass through a OR gate, or this or this or this, so output is F. This is the logic diagram how you will draw. Okay, so let's do one more question. H of A B, if you look here, A B C, M of 1 2 1 3 4 5 6. So how will you draw the K map? As I said, truth table. First is draw the truth table. So you have to write like this: 0 1 2 3 4 5 6 7. You write. Then let's make sections. Okay, after making sections, you will name it A B. Let's move this a bit up. Yeah, here you will write C, and this is the output F. Okay, so As I said, this one you will write 8 digits are there, so 4 zeros, 4 ones blindly, like again 2 zeros, 2 ones, so again 0 1, 0 1, 0 1, 0 1. So at these places the output will be 1 because it is in minimum SOP form. So in SOP form we take only ones. So this one will be 0, this one will be 1, 0, 1, this one will be 1, at 5 place it is 1, at 6 place it is 1, at 7 place it is 0. So if you watch here, so how many digits are there, so you can draw like this also. C I will give here, A and B I will give here. So you have to draw 4 sections. Remember, you have to follow gray code. So here it will be 0 and 1, this one will be 0 0 0 1 1 1, then 1 0, because 1 1 comes first in gray code. The humming distance must be 1. So this is 0, this is 1. Since we are following gray code, so this will be 2, this will be 3. Okay, because 1 1 value, 1 1 has more value than 1 0. And this one will be 4 5, similar concept. This one will be 6, this one will be 7, because 1 1 has more value than 1 0. Then you will write function. This one is 0, this one is 1, this one 2 is 0, 3 is, be careful while writing this. 1, 4 is 1, 5 is 1, 6 is also 1, 7 is 0. So how will you take the SOP? For SOP you have to consider this. And for this one, since in a map they are connected from every side, K map is like connected from this side, they are connected. Okay, so you will, let's take yellow, this one, let's take with black, this one and this one, because you know the maximum number of ones we take, the better form it will be. So the minimized form will be, so what will be the minimized form? This one, just a minute. Yeah, if you look here, the equation of this will be, see here, the A bit is changing, right? If you look, the A bit is changing, but the B bit 0 and 0. If you look for these black parts, 0 and 0, B is not changing, you will write B complement, and C is not changing, so C. But if you look for this one, this equation, you know A is changing but B is not changing, so you will write B. And since C is not changing for both but C is 0, so I will write C complement. If you look for this box, it will be C is not changing, so I will write C. But look here, B is 0 and this is 1, so B is changing and A is not changing, 0 and 0, so I will write A complement and C. So the minimized form F will be A complement C plus C complement B plus B complement C. Okay, this is the minimized form of the equation. We will see more about K maps in the next video. We will do more K map questions. Okay, so in the next video, so this video was basically to make you understand what is logic gates and what is K map, but in the next video we will see how the K maps question work and how, what is the question and everything we will do in the next video.